My name is Laura Marie Coleman, and I'm glad you're joining me for this video today on addition and subtraction word problem situations. In this part 1 video, we're going to be discussing addition and subtraction word problem situations that fall into the categories of add to and take from. For these problems, as we go over them, we're going to be using the RDW approach to problem solving. This means we'll read the problem to get the whole picture. We're going to go back through the story and represent each piece of information with a drawing, and then we're going to use our drawing to decide how to solve and write an equation. The information on these addition and subtraction situations comes from a table that can be found in the progressions documents, the Common Core standards, and many state standards. In this video, we're going to be looking at these first 2 rows in the table, where we're discussing add to and take from problem situations. Each one, add to and take from, also could be classified as result unknown, change unknown, and start unknown. The add to is how the story is set up, and the unknown is going to identify what the question is asking. Here's our first add to problem. 8 frogs are in the pond. 6 more frogs jump in. How many frogs are in the pond now? In our story, we know we start with 8 frogs. I've included 2 different ways students might represent that 8, either in a linear drawing or using a 10 frame. Next in the story, this is where we add to. 6 frogs jump in. We added in 6 more frogs to each drawing. Our question is asking, how many frogs are in the pond now? In other words, we want to know, after we added 6 more, what was the end result? How many are in the pond at the end of the story? The equation for this could be 8 plus 6 equals our total result. Let's take a look at an add to change unknown problem. The bakery had 37 pies. They baked more pies. Now the bakery has 54 pies. How many pies did the bakery make? We know we start in the story with 37 pies. Then we add to those 37 pies when the bakery bakes more, but we don't know how many. The story tells us next that after we baked more pies, we now have 54 pies. And the question is asking us, what was the change? How many more pies did the bakery make during the day? Our equation for this could be represented by saying we had 37 plus some more, an unknown number, equals 54. Let's take a look at an add to start unknown problem. Some fans were at a football game. After the game started, 642 more fans were let into the stadium. Now there are 864 fans at the game. How many fans were at the game before it started? So we know at the start we have some fans there to watch the football game. We know after the game starts, 642 more fans are let into the stadium. The story tells us next that after the 642 more people came in, all the people in the stadium totaled 864. And the question that the story is asking us to solve for is how many people started in the football game? That start unknown. So an equation that matches our story could be we started with some number of fans, we added 642 more, and the total equaled 864. Let's look at some take from problems. The first one is a take from result unknown. There were 12 cookies on the plate. During snack, the students ate 8 cookies. How many cookies are left on the plate? For this one, I give you 3 different ways students might represent it. I might use a 10 frame, I might use a linear model, or if I picture a round plate in my head, I might just draw a plate with a dot for each cookie. I know there's 12 cookies on the plate. Then I learned that the students ate 8 cookies. Students in first grade might cross off those cookies all at once, or they might have to count them and cross them off individually. Either way, I'm going to show that I took 8 cookies away. The question is asking us how many cookies are left on the plate. So our unknown is the result of what was left after students ate snack. Equation for this could be 12 minus 8 equals an unknown number of cookies that are left on the plate. Let's look at a take from change unknown. In this story, there's 142 cars in the parking lot. At lunchtime, some cars left. There are 67 cars in the parking lot now. How many cars left the parking lot at lunchtime? So this story, we know the start. We know we have 142 cars in the parking lot. When lunchtime comes, some cars leave and some cars stay. So in order to decompose the 142 into parts, I'm going to move it to the outside of my tape. This allows me to break apart the tape and label the parts. I know the first part is that some cars left. I don't know how many, but I do know that part of that 142 is gone. So I might want to cross that off in my tape to show that it isn't there anymore. I also know that 67 cars are still there. The question is asking me how many cars left the parking lot at lunchtime. So what I know is the start, I know the end result, but I'm solving for what was the change, how many left. Our last take from scenario is a take from start unknown problem. The school cafeteria made lunches. 124 were sold to students, and there were 8 lunches left. How many lunches did the cafeteria make? So in this story, I know that the cafeteria made the lunches for the school day, but I don't know how many. So I'm going to label it with a question mark. I'm going to move that question mark to the outside when I learn that I have to break it up into parts. And the first part I learn about is that 124 were sold to students, so they got eaten. I also learned that there are 8 left. Notice in this example, I added labels to my tape. It can sometimes help kids keep track of what the different parts are. The question in this scenario is asking, how many lunches did the cafeteria make? So how many did they make to start with? I know that some mystery number of lunches is equal to the 124 lunches that were sold and the 8 that were left over. So this is a possible equation. In summary, it's important to know that problem situations are based on the events of the story, the information provided, and what the question is asking, and that there's multiple types of problem situations for each operation. It's important to be able to identify each word problem situation for a couple reasons. We want to be able to identify the specific problem structures or situations that students are struggling with. And this way, we also need to be able to intentionally create word problems with that specific situation in mind, so we can provide them the practice that they need. Thanks for checking out this video, and I hope you'll visit our website, pimaedu.com, for more videos and resources, and also reach out to us if you're interested in some custom PD or instructional coaching for your school or district. I hope you'll join me for part 2 and 3 on the additional word problem structures.